Hello everyone. So in this session we'll cover the two segmentation methods we use for clustering, that is hierarchical clustering and K-means clustering. So before I start explaining about this, I want you to go through this definition which we discussed in our first session. What is market segmentation? Market segmentation basically means subdividing market into distinct subsets of customers, such that segment members are different between segments but similar within. So if you translate it to the goal of clustering, then we can say that our goal of clustering is to club similar respondents together. Okay? So, if we visualize this, it is something like this. So, the members who are in one segment, say the members who are on this green pie are similar. They have similar needs, similar wants, and there's this underlying assumption is that these homogeneous segments will have comparable purchase behavior and they will respond similarly to different marketing activities. Okay, so the next question comes that how system knows which respondents are similar or dissimilar and how to club them, how to cluster it. So it does this based on distance, and we calculate Euclidean distance for this. So here I show this through this example. Suppose we have these 6 respondents, 1, 2, 3, 4, 5, 6, and I observed this their income in lakhs and their education in years. Okay, and I calculated the distance between respondent first and second just by calculating the distance. This is just distance formula under root x2 minus x1 whole square plus y2 minus y1 whole square, that is 20 minus 20 and 18 minus 16, that's whole square, and this gives me 2. So similarly I computed the distances between all these respondents, first and second, second and third, third and fourth, all these respondents and all these respondents. See, this is dissimilarity matrix. Why dissimilarity? See, because 1 and 1, the distance is 0. That means the dissimilarity is 0. Okay, and if the distance is less, that means that those two respondents are very similar. See, if 2020, the distance will be less, it makes 0. And that's how system knows it, that if the distance between the respondents are between the respondent is less, then those respondents are similar. So what I did next is I created a dendrogram. I checked that first and second clusters have like very less distance between them, that is 2, and I clubbed first and second. Then the next cluster is of third and sixth, because the distance between third and sixth is also 2. Now I have to check what other clusters will combine with these two clusters. So what I did, I checked first and second with 3, first and second with 6, the distance, that is the distance of first with 3, that is 10.2. I just checked the distance of second with third, that is 10.8, and the minimum distance is 10.2. Similarly, I checked distance between first and sixth. First and sixth is 10.8, and distance between second and sixth is 11.6, and the minimum of this is 10.8. And similarly, to arrive at the distance where first, second and third sixth will meet, I computed this through the minimum distance between 10.2 and 10.8, so it comes out to be 10.2. Similarly, I check the distance between first, second and fourth, fifth. So first, second and fourth, that is respondent first and fourth is 5.8, respondent for second and fourth is 5.1, minimum is 5.1. Respondent first and 5 is 7.8, second and 5 is 6.4, second and 5 is 6.4, and for second 4 5 distance is 5.1. So because this distance 5.1 is lower than this, So these will meet first. So first, second and fourth, fifth, I joined it on 5.1. Similarly, I checked the distance between 4, 5 and 3, 6 and it came out to be 7.1. So this is how you can make dendrogram. So this is basically the joining distance, that is these distances, okay, and the one that we computed when, after one and first and second respondent join, we need to check whether to join with the distance which is between first, second and fourth, or whether to join the distance which is between first, second and fifth. And we check both of these distances, and then we arrive at the minimum distance, because we are going with the minimum linkage. So this is how you can draw this dendrogram. You can arrive at this dendrogram. So the next thing here is, from this dendrogram you can see which cluster of respondents joined first, and so these respondents are like very similar. So the joining distance, here it is. So the respondents, those were like joined like first, these are the these were the most similar ones, and then the joining distance may be here at this joining distance, which is somewhat like less than 5. These respondents like were much more closer, much more similar, and so they joined first. And then at this distance join, and this distance, and similarly you can see that respondents who joined really late, or rather I should say the clusters, this cluster and these two joined really late, and these were like quite dissimilar. You can also take one branch and you can check the respondent, because it's like much more clearer here that these were the respondents, and you can also see the distance of these respondents, and the distance between these respondents will be similar. 57, 39, the distance will be same, and 46, between 46 and 27, the distance will be same. And whereas the distance, because these respondent and the ones which are in this cluster joined late, so if you see distance between 120, 102 will be less compared to distance between say 85 and 50, or between 85 and 44. Okay, so this is how you can see how these respondent joined sequentially based on the joining distance. Next comes our K-means. So the goal is same, that is we have to find clusters that are similar. In K-means we give numbers of clusters. The number of clusters are already defined, and we ask K-mean to identify those number of clusters. So what K-means does is, like if in hierarchical clustering I find out by this dendrogram that 3 clusters make sense. We don't want to cut the tree at a very large distance. We don't want to cut the tree at a very small distance. That will give me a large number of clusters. We don't want to do that. So I'll cut the tree somewhere here, and I arrive at 3 cluster solution. So now what I'll do is, in K-means clustering, I'll put K equals to 3. By the way, K means number of clusters, and which we have to give, and means centroid or mean. Okay, so let's see of this. This is very simple example. If I told you to create 3 groups for the points below and draw a star where the middle of each group would be, it would be something like this. You will draw these 3 clusters and these 3 clusters, and you put a star the middle of each group, so which is kind of centroid. So what K-means does is it calculates the distance of each point with the centroid and tries to minimize the distance between all the points and the midpoint of the cluster they belong to. Okay, so this is one thing. You can check from here also. The aim is to minimize the within cluster variation, which is defined as the sum of the square of the Euclidean distance between each data point to the centroid of its cluster. So, like I said, it minimizes the within cluster variance. And how it minimizes? By minimizing the distance between centroid and the data points of that cluster. So let's see step by step how K-means does this. So suppose we have these data points. Let's say I have this sample of 160 and I realize that by doing hierarchical clustering there are 3 clusters. So I give this input to while running the K-means clustering that I need 3 clusters, and now it is up to K-mean that how it identifies it. So the algorithm that K-means does is that it will first select 3 initial clusters. Okay, randomly it will select 3 data points which are the initial clusters, and from one point just select first point, and it will calculate the measure the distance between the first point and these clusters. That is the Euclidean distance. So it will check the distance between the initial point and the blue cluster. It will then check the distance between first and this green cluster, and similarly it will check the distance between this initial point between this and this third cluster. And similarly with all these points, K-means will do the same thing with all these points. And once all the points are in clusters like this, we go to step 5. And step 5 is we calculate the mean of each clusters. Say this is the mean of each cluster, and it measures the distance of a point with the mean of each cluster and try to minimize it, and it will keep on running and keep on doing this calculation until it does it to the number of iteration we ask it to do it. And K-means will keep on doing this iteration so until the cluster assignment doesn't change. Okay, so the difference between the two clustering methods is that hierarchical clustering tells you pairwise what two things are most similar, whereas K-means clustering specifically tries to put the data into the number of clusters you tell it to. So from hierarchical clustering, say we calculated that we find out by dendrogram that the number of clusters should be 3, and we input this number in K-mean clustering, and K-mean clustering through running its algorithm that I discussed here by minimizing the distance between data points and centroid of each cluster. It does that number of times we ask it to do, and then it calculate what is the total variance and arrive at the best cluster solution. So there's one more thing here, that is this output. We get this output in K-mean clustering, and we can see by what are the cluster sizes by K-means. So it's 64, 48 and 48, and we can also see the cluster means. So the first cluster is loading high on shopping is fun, is high, and on combining shopping and eating. And similarly you can check second cluster is loading high on budget shopping, get best buys, and comparing prices, all this. Next is this clustering vector. So the observation which is in first cluster, this first is in first cluster, second is in first cluster, the third observation is in second cluster. It just tells you the membership of each respondent. Okay. Next is within cluster sum of squares by cluster. We This was the goal, that if there are these 2, 3, whatever number of clusters, K-means tries to minimize the within cluster sum of a square, basically within cluster variance. So if a cluster has like the distance between the mean and the data points is small, okay, the sum of a square distance is small, that means it's like more similar, okay, and it's like more compact, they are more similar. So if if you see these three values, so it tells you that 70.3 is lowest, which means the third cluster is like has like a more similarity, the distance between the within cluster sum of a square, or the distance between the centroid and the data points is minimum, they are like more compact in this third cluster. So in cluster, if we have like the within cluster sum of a square should be minimum, and the between sum of a square should be high, so that they are like distinct, they are different, okay. And you can see it from here, 73.2%. If you want, if there is if you are not doing hierarchical clustering and you want to do it just by k-means, so what you can do, you can instead of 3 you can check with k equals to 2, k equals to 4, k equals to 5, k equals to 6, and you can see what value you are getting here. And but when the total variation will always increase whenever you will increase the number of clusters, so it will increase, but then you will get one elbow point, it's kind of a scree plot, one elbow point where the variation, the increment in variation is not that steep. So that is the optimum number of clusters. Like say I got this on number of clusters where the number of clusters is 3, and then the optimum number of clusters that K-means is suggesting is 3. So that was all on hierarchical and K-means clustering. You can go through the videos that I discussed in class. Thank you.